Hey everyone, Mr. Geiselman here to talk a little bit about energy and work today. And tomorrow we'll get into power. So we're starting our new unit. And today we get to start with energy, work, and power. So, what does it mean to do work? Think about that for a second and pause the video and take a second and think, what does it mean to do work? If you're doing work, what does that actually mean? So take a second, think about it. What does it mean to do work? So, what is work? Work causes an object to change its position or speed, and it's a force applied multiplied by the distance it's traveled. So, work is really the force applied, how strong that force is applied to an object over how long that object was, or that force was acting on that object. One of the cool things about work is work changes an object's energy. So it can make an object's energy go up, it can make an object's energy go down. And then we can really start to see some changes in how that object is moving or what it's doing. So the unit for work, we use the unit of joules. And we'll kind of get into that more. What is a joule and how do we get to a joule? And there's a really nice equation. For work, work is equal to the force of the object times the distance that the force was applied to the object. So the work done on the object is equal to the force on that object multiplied by the length that the force was applied. So the distance that the force was applied. So that brings us to energy. We said that work is the ability to has the ability to change an object's energy. So what does energy mean? And energy is really just the ability to do work. So when we look at work, we're measuring it in energy, and energy in the end is just the ability to do work. So they kind of go hand in hand. The unit for energy is the joule, just like it was for work. So energy is equal to force applied to an object times distance, because work is energy, energy is work. They're pretty much the same thing. So if an object has energy, it has the ability to do work. If work has been done to an object, we have changed its energy. So in this picture, all right, is work being done? You lift a weight and move it over your head. Is work being done in this picture? All right, in the next one, you're holding the weight now over your head. Is work being done? Yes or no? Now, is work being done as you're trying to lift a weight, but it's too heavy and you aren't able to move it? So you're lifting on the weight as hard as you can, you're trying as hard as you can, but you can't move it. Is work being done? So hopefully you realize that in order for work to happen, there had to be a force over a distance. So here's a practice problem for us. Imagine a father playing with his son by lifting him repeatedly in the air. How much work does he do with each lift if he lifts him 2 meters and exerts a force of 190 newtons? So try and figure this one out. We'll go through it here in just a sec. Okay, hopefully you did your best to figure this one out. So we're going to go through this one together, and we're going to give this one a shot. So in the picture, we have got our dad holding his son, little son, and he's throwing him in the air, right? He's throwing him up into the air. It's not the greatest picture in the world, but you guys get the idea. So he's lifting the son up and down, up and down. So he's lifting him up, letting him come down. Again, not a great picture. So he's lifting him up into the air. All right. So that's the initial situation. Here's the situation at the end. We got our little boy in the air. I don't know why this doesn't seem to really like to write. Sorry, guys, I'm trying out a new pen for the Chromebooks. So that's the kid in the air. Here's dad on the ground. Right? We've lifted him up into the air. Has he changed the kid's position, right? Has he changed his speed, or has there been no change? Well, obviously, he's in a new place now. So he's in a new place, and to get there, he had to have a new speed, right? But it doesn't give us that information. So we're just going to say he's in a new place, right? So we need to figure out what the work done was, right? So we're going to try and figure out how much work was done on this, or in this problem. We do know a few things. We know that he exerted a force of 190 newtons over a distance of 2 meters. And if we use work equals force times distance, we can now substitute in work equals force of 190 newtons times 2 meters. And when we punch that into a calculator, we get an answer of work equals 380 joules. So we get a new answer of, 380 joules. So one more practice problem, and then we'll be done for the day. A weightlifter holds a barbell over her head. If the barbell weighs 500 newtons and it remains in the same location, how much work did the weightlifter do? Give you guys a second to figure this one out. Give it a shot. So with this one, all right, a little different scenario. We have a weightlifter. There's her barbell. Goodness, I'm having a tough time drawing with this tool. The weightlifter is holding a barbell above her head, except I can't draw that. The barbell is above her head. At the end, the barbell is still above her head. So there has been no change. Done. We do know that the force on the barbell, the weight of it, is 500 newtons, but it has moved a distance of 0 meters. Well, how much work was done? We'll use our equation work equals force times distance, and we'll substitute in work equals 500 newtons times 0 meters. And when we figure this one out, work equals 500 times 0 is equal to 0 joules of work done. All right. So hopefully you found this pretty easy, and we should be good. This is a pretty simple thing. Work equals force times distance. All right. So as long as you have a force and a distance, you're able to find work. If you have any questions, give Mr. Oleg, Mr. Swenson, or myself a call, and we'll help you figure it out. Have a great day, everybody.